let me just quickly recap what the session is going about basically, and then we will talk about what the course and what the whole initiative is actually about. So what we're going to do today is basically, this is an introductory day, so we're not going to go to some kind of, deep syntax investigations, learning what, I don't know, promises are. We're not going to do anything like that. However, we are going to talk about what JavaScript is. We're going to take a slight glance at what the history of JS looks like and how it progressed during the years. And we'll also talk about the syntax, but I'm sure the people who are on the call are already experienced with writing some, I don't know, JavaScript code or whatever code it is, maybe even some Cypress tests. So you know this, but this is the introductory day, and we're going to go through this together. Yeah, so that's the plan for the first day, the introductory day. So what I'm going to actually do right now, I'm going to start with my session, and I'm going to kick things off with the history of JavaScript. So yeah, it actually basically started all from 1993, almost 30 years ago, with a Mosaic browser. It's, as you can see on the left top side, it looks extremely archaic at the moment. We just cannot compare what they had at the time with I don't know, Google Chrome or Safari browser or Mozilla Firefox, what we have today, these modern browsers. But Mosaic was the best at the time. It was 1993. And some of the people there decided that it was not going well for them. I mean, the kind of course that the company or the Mosaic browser was taking. So they basically decided, hey, why not just kind of leave all these and let's go build our own thing. So they founded the Netscape Communications Corporation, or just simply Netscape. And in 1994, the Netscape Navigator browser was released, and it was actually the best they had for some time. And in 1993, and of course at the time, in the 90s, in the beginning of 90s, 1993, 94, the web was, the internet was very static. There were some images, of course, some I don't know, hyperlinks, maybe some styling, but there was not really any kind of dynamic things going on the web pages. So you didn't have too much kind of interaction. So to stay on the top of the wave, basically, Netscape decided to kind of integrate some kind of programming language into their browser. And in 1995, the famous engineer who is currently behind the Brave browser, he's the founder and CEO of the Brave company, and that company is behind the Brave browser called Brave. So Brendan Eich, he engineered the kind of archetype of JavaScript. It was initially called Mocha, then LiveScript, and then it was kind of rebranded into JavaScript. And the fascinating thing is, he did it in 10 days. It was both kind of good and bad, because it was good because Netscape was able, with introduction of JavaScript, to just really stay on the top of the wave, just be top-notch, browser with all these kind of interactions. However, when you design something, when you design a building in 10 days, you just cannot expect that the foundation of that building is going to be amazing, because you just did things in such a quick manner that it just cannot be done. So unfortunately, the flip side of the coin is that he introduced many design kind of issues and problems that are still with us after 30 years. Almost 30 years, the language was created. So what happens next? Microsoft starts picking up the pace, and they are and they release their Internet Explorer browser, and they also spin off their kind of own version of JavaScript thing that is called JScript. And of course, Internet Explorer ceased to kind of exist last year or something like that. I'm not sure if JScript is even used anymore, but what I do know is that in their operating system in Windows, JScript was used to run these scripts. So not only the browser, but also in the operating system. Okay, so a couple of years later, since the Internet Explorer is starting to pick up the competition, and we have Netscape Navigator, well know that JavaScript language kind of the inception was in that Netscape Navigator browser, and we also have Internet Explorer. So you have basically two rivals that are just trying to push things to their limits. And in 1995, what Netscape does, they just decide to kind of submit a first official kind of standard of a language, and that standard is called ECMAScript, and it is called ECMAScript because of the name JavaScript. So let me quickly go to the next slide, and then I'll come back. So why is the language called JavaScript? It's because the Netscape, the company behind Brendan Eich at the time, they just decided that since Java was a cool language at the time, it was Sun Microsystems, currently it's Oracle, this new hot language, it was just getting too much attraction at the time. It was growing exponentially, so everyone was into Java. So Netscape said, hey, yeah, let's do the marketing thing. Why not? We're business people. Let's just name this new language JavaScript after Java. And that just single-handedly broke the internet for the upcoming decades in a way that, I don't know, I think the number of memes and controversies that came from this are just countless. So that's basically how the name JavaScript was assigned to the language. So if we now come back to the standardization of the language itself, as I mentioned, the standard was called ECMAScript, and ECMA is the kind of the international kind of committee or the company. They're a company who standardize things. So since the name ECMAScript was available, and it was the ECMA organization who was doing the standardization, it was decided that in the standard they are going to refer it to as ECMAScript instead of JavaScript, because all the rights of the name, all the copyrights of the name JavaScript belong to Oracle to this day. So the last part of the history, I just did some very quick kind of fast forward, but it was in 1995 we have the first standard called ECMAScript 1, and then during the years, very quickly, I think it was a couple of years of iterations, they pushed the second version of the standard, then the third version of the standard. And in 2009, the fifth version of the standard was published, and 2009 and 2008, both of these years are kind of like Rubicon, right? So we have the Chrome browser released by Google, and then Google starts doing some asynchronous JavaScript stuff in their Gmail product that never have seen or even think about before. So it was pretty cool at the time. Nowadays, it's really kind of simple and normal. But back in the day, in 2008, it was just super cool, like some artificial intelligence stuff right now. So it was that cool back then. And in 2009, Ryan Dahl, single-handedly, he was the only engineer at the time. He created the Node.js application. It's an environment where your JavaScript code can run on the server. So before Node.js, there were a few attempts where people trying to run their JavaScript code on the server, but Node.js was that kind of critical point where it just clicked, and it had the traction, and all the community started together around Node.js, and we can consider 2008 and 2009 one of the most important years of the language itself, because that is when it actually started to really grow exponentially. If you notice, I didn't mention the ECMAScript 4, version 4. I said it was 1997 where the first version published. Then I said in the course of a couple of years, they had the second and third version published. The fifth version was published in 2009. However, the fourth version was never published because it was just such an ambitious kind of project. It was so huge that the companies, just so you know, there is no one company who works on the standard of JavaScript. There are a bunch of companies who basically collaborate currently each year to push new versions of the language, and the ECMAScript 4 standard was just so big and it was humongous that they were just not able to kind of agree on things, and then there was just too much to bring into the language. So the ECMAScript 4 standard was dropped after some debates. However, some of the language features, like for example promises, were later introduced in the ECMAScript 6, which is the 2015 version of the standard. All right, so we've heard that script in JavaScript, right? So basically, what is the script? And the script is just the textual representation of your code. In JavaScript, it's usually the .js file that you can load in your web pages, and what you see here is the contents of just a random web page that I picked up. So and you can see that these JavaScript files are being loaded into the web page. You know, the red ones, the ones that are highlighted with red lines. So basically, the way you kind of do load your things into the page, you just put your code in the .js file and then use this script thing to load it into your web page. So that's the basic way I can put of how you would load your things in a web page. Okay. However, let me jump ahead. We will not be talking about this because you do not really, I don't think you really need it for this accelerated course. But just so you know, very recently, another extension was added. It is called MJS. So it's not only the .js extension, but there is also an .mjs extension. And another extension that we're also will be interested in is the .ts extension, and the TS stands for TypeScript. Okay, so we're going to talk about the alphabet of the language, and one of the first places you start is the reserved words of a programming language. I'm sure some of you know like lots of these keywords, and this is a partial list, and as I mentioned in the slide, as of ECMAScript 5.6, because originally there were there were many more other reserved keywords in the language. However, in ECMAScript 5, which is the 2009 standard, and ECMAScript 6, the 2015 standard, some of the keywords were removed and some of them marked as asterisks. Asterisks were added, like enum, import, export, and extend. So what is a reserved keyword? So these are basically some tokens, right? So some names that you are prohibited from using in your script. So for example, you cannot have a variable, right? So let's assume we know what a variable is. I'm sure you do. We'll be talking about that in the next session. So I suggest we do not go into the very details of any code or anything you see on the screen right now. This is an introductory course, so I'm just kind of introducing you to the basics of the language, and I'm sure you know that. However, let's continue with that having in mind. Yeah, so for example, you cannot have, I don't know, a variable name called finally. Why? Because that's a reserved keyword, and the compiler or your runtime, and in this case, the the V8 engine of our Chrome browser, we'll just let you know that this is an unexpected token. As you can see in the screenshot below, I tried to use the true reserved word, and true is a Boolean value, as we will see in our next session. And it is also a reserved word, as you can see also in the list of the reserved words, in the reserved keywords. You cannot use it as a variable name. So just think of reserved keywords, some kind of tokens, strings, names that you cannot use as a variable name, as a function name, as a class name, etc. So just be careful with them. And also in the current tools like IDEs, text editors, these keywords are usually highlighted slightly differently than your string values or numeric values. So you will also be able to visually differentiate them very easily. Awesome. So let me just quickly go through the chat and answer the questions, and we'll have like a 30-minute break right now. Okay. See, appreciation, Sentinel. Yeah, sure. And this is, by the way, also a great opportunity for me to learn. Whether you believe it or not, there are lots of kind of tricky parts that we developers also do not come across every day. And in preparing these courses, me personally will also go through all of this stuff. So it's also very interesting for me, and also very valuable for me to be doing this course. So no worries there. Okay, so there's a question in the chat, which engine will not let to use? Maybe if you can clarify what the question is about, the reserved. Yeah, so there is a possibility that in the older versions of some engines which target, some old version of JavaScript, you might be able to use some of the keywords. And I will also, at the end of this session, introduce you to the strict mode of JavaScript, and we will see when you enable that mode, you will also not be able to use some other words as variable names and function names. So this is slightly varying from case to case, but what I showed you on the screen, on the previous screen, so these keywords you should not normally be able to use in any engine. There might be some exceptions. I'm not aware of every single JavaScript engine that is out there. And there are some slight implementation differences between them. However, you should just know that the list of the keywords that you see on the screen is a reserved one, and you should not be able to use them as variable names or function names. So the answer to the question is that might depend, but generally you should not be able to use them in any engine. Oh wow, okay, so we're having some kind of time limitation here. Okay, so it seems we might have to drop the call in about 10 minutes, and then we will be rejoining the call. We might also need to, we'll just do some couple of minutes of rest and we'll continue. However, let me continue with a more interesting part of the language. So the interesting thing regarding the syntax of the language, especially JavaScript, even if you know the syntax, if you do not understand the core concepts of how your script works, how it runs, especially the asynchronous code, it's going to be extremely hard to sometimes, just wrap your head around the code, how it works, or even just debug things, because the code is going to behave in an unexpected manner, and if you do not understand how the code is being how the synchronous code is being executed, and how the asynchronous code is going to work, if you are not familiar with the callback, with the concept of callback hell, etc., we're going to get into all this in depth in the upcoming sessions. So no worries. This is just an introduction. It will be hard for a developer to do some real world JavaScript stuff. So what I have for you here, I have two concepts that we have in JavaScript, right? So the first one is the synchronous execution of your script. So if you recall, in one of the previous let me see if I can find it. Yeah, in one of the previous screens, I showed you that we can load our script, which I said is the textual representation of your code, into your browser. But how is the browser going to, do all that? How it is going to kind of understand all this? So what your usual engine does, including the browser, your Node.js environment. So what they do first is they go through your code, your JavaScript file, from top to bottom. So that's how it works, not from the bottom to top, but from top to bottom, line by line. They will try to parse your textual JavaScript file, and the engine will try to understand what you are trying to say here. So for example, on the first line here, what we try to tell or instruct to our engine is to just do some work synchronously. And synchronously, doing something synchronously means unless that job is done, you do not continue. So that means your engine, your browser, Node.js environment, whatever it is, Cypress, it doesn't matter. Whatever environment your JavaScript code is running, if it is running in a synchronous manner, your code will execute from top to bottom. Line 1, line 2, 3, 4, 5, etc. So it will be very intuitive for you to debug things. The outcome of your code will be extremely predictable because your code just goes from top to bottom. It's very easy to understand the code, to wrap your head around your code, because it just works the way you read the text. And the way you read the text, I mean the normal text, for example, book, whatever article, you just read it from top to bottom in English, of course. And the same is here. The synchronous code is like that article. It just executes from top to bottom. So unless the very first line here, the do work synchronously function, does not finish, you do not continue to do some more stuff function. So that's how the synchronous execution works. And a quick example of the synchronous a synchronous execution in real life would be a phone call, but not the phone call that you just kind of ignore and then the person talks and you do some stuff, but the important ones, when someone calls you and they really need your attention, and so you are going to stay on the call, you are going to listen to them attentively, you're trying to understand them, and then you respond. So what you do is you first wait to receive all the input from the other person, hence the synchronous manner of the work, and then you are going to respond. That's basically how the code here works. So the input here for the engine is this function on the first line. It receives, it parses, it tokenizes it. I'll explain it what tokenizing means in the next lessons. So it tries to understand your code here. For the engine, the input is this function. It executes the function. Unless the function finishes its execution, it does not continue. Hence the example with phone calls here, but the important ones. So someone is smiling here. So this one is an example of this is an example of an exception of what I showed before, because we all know our heroic Marshrutka drivers can just multitask like crazy, and they can do all stuff simultaneously. They can talk, they can give you the change, they can drink, they can drive, you name it, they can do it simultaneously. So this example does not kind of concern the phone call example does not concern them. So they are an exception. Okay, so I can see we have 4 minutes left. So the next the next manner of executing our code in JavaScript, this is the second and the last manner. So we have two ways of executing code, depending how we write it, depending on the concepts we use, depending on the primitives we use, depending we're using promises, whatever it is, we'll talk about later. So what is an asynchronous execution of something? For example, imagine you are making a network request. You are trying to fetch some kind of data from a backend. I cannot imagine in a million years that could be a synchronous execution. However, technically it could, but imagine that you try to request something and the whole kind of world kind of freezes to respond you. It doesn't work. It doesn't work in real world, right? So you just request something, and whenever that thing is ready, they just give it back to you. They somehow know your context, so they will call you or they'll deliver it to you. But for sure, you do not have to kind of just stand there for, I don't know, 5 days for you to get the package. So that's this would be an example of an asynchronous operation. And with asynchronous, things start to work slightly differently here. And we do still have these two functions that do work asynchronously and do some more stuff. However, now our first function works asynchronously, so it does not behave in the manner that with our synchronous do work synchronously function behave. So whenever the engine, your JavaScript engine sees the first line, it then somehow knows that this code is going to execute in an asynchronous manner. And then what it does, it quickly goes through all the lines up to line 6, and then it executes your synchronous stuff. So it is very hard to wrap your head around that, because when you see this, you expect that the do work asynchronously should finish before you do some other stuff. But actually what happens, some other stuff will be done first and your asynchronous stuff will be done later. So it's counterintuitive, because on the script, it's vice versa. You have the asynchronous stuff before the do some more stuff function, but actually the execution wise, it happens the other way around. So, and this is where we come to the concept of the callback hell. However, we're not touching callback hell here, or promises, or whatever it is. We'll deal with them in future sessions. So imagine you are standing in the queue here, and you are trying to buy a coffee from Starbucks. By the way, if you don't know, Starbucks is like McDonald's of coffee, right? They're everywhere, and then they do coffee, whatever is their thing. So you're on the line, and of course, the process of waiting itself is a kind of synchronous process. So you will have to wait for the person in front of you to move, and then you can move, right? If you are not arrogant enough or rude enough to just circle back all that queue and just go straight to the desk, you're just going to wait in the queue. So that's a synchronous process. However, when you arrive to the desk and you start ordering something, that is also a synchronous process. But when Starbucks receives your order, then the asynchronous process starts, because they do their stuff, you can do your stuff, you can be on your phone, you can go for a walk for a couple of minutes, so you can just be completely kind of busy with some other stuff, and not just wait in front of the desk. You are not in a queue anymore. You don't have to wait in the queue or in front of the desk. You can just do your stuff, and whenever your coffee is ready, they will call your name. The keyword here is call your name, and we'll see why this is a keyword, because we will be getting to the concept of these callback functions, right? We're not going to discuss this. Maybe you know what a callback function is. However, I try to choose that word, to call your name. So we have the analogy with callbacks. So whenever your coffee is ready, your order, let's say order, whenever your order is ready, they will just let you know. They will call your name. Usually, well, Starbucks, they do it that way. They write down your name on the cup, and whenever your order is ready, they just call your name, like literally call your name. And that's how you know that your order is ready. So basically, you just do not wait again in the queue. You just do not stand in front of the desk until it is ready. No, it doesn't work that way in Starbucks. They write down your name so they know whenever you what you have requested from them, your order. Whenever your order is ready, they will let you know. They will call your name. So that's how it works. And this is an example of an asynchronous process. And we shall see the kind of analogs of this in JavaScript code later on in one of the sessions when we arrive to the concept of asynchronous execution. Okay, so also just to be on the safe side, we're going to discuss some naming conventions or naming conventions in JavaScript. I will also tell you the way, if you would like to piss me off, I will also tell you a very good approach to piss me off, if you would like to do that for whatever reason it is. So let's start with constants. Constants, well, you can, in the scope of this slideshow, just think of constants of values that are not meant to change ever, right? So an example of a constant is the actual mathematical pi constant. It's an actual value. And what we can see is that the constants, well, the agreement, the naming convention is that the constants are written in uppercase in JavaScript, as you can see on the right side. What is this math? We'll talk about that in a later session. Okay, so we took care of constant. Now let's get to variables and function names. What is a variable? What is a function name? Doesn't matter. Just know that these are some names of the things, right? Some namings, right? We're naming some things, variables and functions, whatever they are. We'll discuss them in the upcoming sessions. Okay, so just what we need to know is that these two things, variables and functions, are usually named in so-called camel case, and the way camel case works is that your very first letter is in the lowercase, and you are kind of combining words to create a name for your entity or your thing, which whether it's variable or function. You just starting from the second word in this example, it's for example, do work, right? We have two words. We're trying to compose a name of a function, and the name of the function is do work. So in camel case, the letter D of the word do will be lowercase, and then starting each word, the first letter of that word will be uppercase. And we also have an example of a variable underneath on line 5. So the name of the variable is vehicle address. So the first word, again, this is a variable, so it should be written in the camel case. So the V is in lowercase, and the first letter of the second word, address, or the letter A, is in uppercase. And also a convention is not only in JavaScript, but in a lot of languages. It is a convention that you start your class name is written in the Pascal case. Pascal case is basically the same as camel case, with the very first letter also in uppercase. So there's the kind of only difference between them. Yeah, and the way that I was going to tell you that if you would like to piss me off, you can just write things in the Python manner, which is, for example, if we take this vehicle address, this variable name vehicle address. So in the Python world, the way you would write this is vehicle underscore address, and address, the letter A would be in small case. So that would be the Python way of doing things. And we do not do that in JavaScript. So just some general naming convention so that you know we generally use in JavaScript. Another quick topic I would like to discuss is the coding style. This is actually quite a personal choice, and there are when I say a personal choice, imagine you are the sole developer working on a project, right? So you are the only developer, and in that case you can just choose whatever coding style you want, right? You can just write your code in any manner you would like. However, it's slightly different in teams, right? Because in teams we have multiple people, and the real world is made in a way that the other people review what you do, your code, and you review the other people's code. And imagine you have 5 people working on the project, and each of them write in their distinct kind of personal code. They have their own distinct kind of coding style. I think you can imagine the mess that is going to be created in that code base. So a few years ago, this tool was created. It's called Prettier. It just formats the code for you. It's not super configurable. That's basically the idea. It's an opinionated tool. It provides it does some decision. It provides some opinions for you, so you don't have to kind of bicker inside your team around what the coding. Are you going to put a new line after this? Are you going to put a semicolon there, or are you going to put some spaces between your I don't know, function brackets, whatever it is? So Prettier just single-handedly kind of solve this issue in JavaScript, and in whatever project you use it, you just have a very nice, let's put it that way, some coding style and formatting of your code, and you and your team member just kind of decide on small kind of configurations of stuff. And even if you write in your personal style, this tool will convert it into its style. So in the end, when you're reviewing someone else's code, it's just a standard way of writing things. So yeah, that's about coding style. And there are actually very kind of popular coding styles in JavaScript. One from the Google, the company Google. They have their own style of doing things. I'm deliberately not showing code examples here to just not confuse you. I'm just trying to discuss the concepts here. And also, if you are familiar with the company, with Airbnb, it's a very popular company, similar to Booking.com. They also do have their own JavaScript, TypeScript engineering teams, and they have their own also styling of doing their own style of formatting code, and it's actually a very popular one in the whole JavaScript community. So there are quite a few variations here. You can have your personal style. However, I recommend you just take something like, for example, Airbnb style, and you don't have to learn it because you have Prettier, right? You just use the tool and it fixes this issue for you. So what I'm trying to say is, do not try to during this course, or even outside of the course, do not try to concentrate much on how are you going to format your code. Just try to concentrate on the logic and the execution. Because if you do not understand how the asynchronous code works, it doesn't matter how you format it. Yeah, okay. So I have a quick video of some strange parts of JavaScript. If you recall, we've discussed that the language was basically invented, designed, and created in about 10 days by Brendan Eich, and there would have been some kind of design issues in the language anyways. So we're going to see a couple of strange things here. I recommend you do not kind of do a deep dive how it works. I'm just going to show you that this language is not perfect. There are many tricky parts that we do not usually come across to. There are lots of tricky parts I don't know because I don't come across them in my usual coding. But you can get really weird with JavaScript. So we're going to see a couple of examples here. And I'm going to just live kind of transcribe for you. So what we're doing here, or what the person is doing in the video, is they are just trying to kind of, yeah, oh, sorry, I just switched the slide. Sorry about that. Okay, let me use the touch bar. Okay. So what this person is doing in the video is, on the left side they are writing some code, and on the right side they are executing the code in Node.js that we discussed, that was invented in 2009. And what we have here, I'm sure you can recognize the console log function. It just logs things in your terminal, and you can also recognize this the true, and if you recall, it's actually a reserved word, so we cannot use it for a variable name. However, it is used as a value here, and you might be familiar with booleans. We will discuss booleans and numbers and strings in the upcoming sessions. Right. So what we're trying to do is, we are trying to do trying to apply a mathematical expression to a Boolean type. So that's what the person is trying to do. And on the right side, they are executing the code. And as you can see, true plus true is 2 in JavaScript. How weird is that? Would you guess that? So it's true. However, it's the way the type conversion works in JavaScript. We will also talk about that in one of our future lessons. And so the next example is a really strange one. So if you add 0.1 and 0.2 together, it does not strictly equal to 0.3 as it would do normally in some other programming languages. This is extremely weird. This is unexpected. As you can see, we have this 4 on the very right side of the number, and so 0.1 plus 0.2 is not actually equal to 0.3. So that's classic JavaScript there. And why this happens, we will talk when we get to the numbers. That's next session. Yeah, so let's see what they have for us next. So it was 0.1 plus 0.2. Yeah, so math.max is a function which returns the maximum kind of number from the given set, and we did not provide any value to math.max, and it just returned minus infinity. How natural is that? I mean, the maximum number is minus infinity. That's just great. And things get even better when the .mean function, which returns the minimum number of the given set, returns the other kind of infinity. So the minimum number is infinity. That's also very intuitive. Yeah, and in this next example, this is a super kind of tricky thing. You would have to know how really type conversion works in JavaScript to understand how this works. I don't understand how this works. I don't use this in my normal work, the day-to-day job. So if you know how this works, we can discuss that. I'm sure I can look up the explanation somewhere, but this is one of those quirky and strangest part of JavaScript that you do not normally do in your day-to-day job. You do not add two arrays together. So this type of tricky, I would say useless questions are being asked during interviews. Well, it might not be so useless, because if you can explain how this works, then you for sure know how type conversions work. But given how often do these type of things appear in your day-to-day jobs, which is nearly like 0 chance you would do something like this in your day-to-day job, it's one of these tricky parts. So what we're trying to do here is we're trying to apply some mathematical expression, which is the addition to some arrays, and then this exclamation mark stands for the negation or not, the not operator. We'll also talk about this in one of our later session. And can you just imagine, you get a number. How can you add two or three arrays together and get the number 9? It's just not logical at all. So, but that's how the type conversion works in JavaScript. And when you know how type conversion works, and when you know that when there are two different types of values, I mean, when the operands of your plus sign or your addition operator are two different types, what are these types are going to convert it to exactly? And when you know the answers to these questions, you know, just explaining something like this is extremely easy. However, from the first sight, it's just completely illogical. All right, let's see what we've got here. Okay, so another example of using the plus sign, and in this case we get 51, and the kind of the engine treats this as a string concatenation, so it just kind of combines things together instead of saying 6. However, let's see what happens next. Now when we switch from plus to minus, so the previous example was plus 5, the number 5 plus 1 as a string, so the result was 51, so both of them were kind of concatenated. But when we switch from the plus sign to the minus sign, so now it's 5 the number minus 1 the string, we get 4. It's like, how great is this? It's just awesome. We're having a great time here. Okay, so this was a quick introduction to the strangest part. Well, I wouldn't say the strangest, but some of the quirks of the language, some of the things that do not function the way you would imagine they would function. For example, when you add two arrays, maybe you would expect we will get another array with the kind of elements combined together, or maybe we'll get an error, but no, we get some numbers. So try to wrap your head around that. Yeah, so and just for that was just the beginning of the strangeness of JavaScript. You can just find endless examples of how to break your head or break your brain with, you know, these strange examples from JavaScript. So yeah, it's crazy. I can create an example where the same variable is simultaneously equal to multiple numbers, like a is equal to 1 and a is equal to 2 and a is equal to 3, etc. And it is actually true in JavaScript. However, how can 10 be both equal to 10 and 11 and 12? It's just not possible, but things are possible in JavaScript. So you will not only be a developer, a JavaScript developer when you learn JavaScript, you will also be a magician. That's for sure. Yeah, okay, so I think that's it for the strange parts of JavaScript. We can, of course, like go into the deepest and darkest parts there, but I don't see the point. So let's wrap it up with the strange parts. Now I would like us to also look at the modern JavaScript. As you recall, the very first version of JavaScript was, the standard was published or submitted by the Netscape Corporation in 1997. And then very quickly, in the span of a couple of years, we had the second and third versions published, also in ECMA. And in 2008 and 2009, we had two versions of ECMAScript 5 published. And then in 2011, we get the 5.1 version published. And in 2015 is actually where things start to get really interesting, because as you can see, as I explained, the very first revision of the standard, 1997. The fifth revision of the language, 2009. The 5.1 version, 2011. And starting from the 6th edition of ECMAScript, or the standard, by the way, ECMA-262 is the kind of official name of the standard in ECMA designation. It's the ECMA designation of the standard. So starting 2015, as you can see, each year we have a new version pumped out regularly. So this is where the community, the big companies like Google, Apple, all these FAANG companies and all the players in the market started to really get serious about JavaScript. They started to push things beyond possible. It was also during this time where the frameworks like Angular, Backbone, Knockouts got very popular. It was 2013, the creation of React.js, that we are basically all the front-end engineers, almost all front-end engineers use it here at Service Titan to develop the product for our customers. That's the library that we use, React.js. So it was created in 2013, and with Node.js being created in 2009, and React.js being created in React.js being created in 2013, things in JavaScript world just started to grow exponentially. They got out of hand, and it was pretty obvious to the community, to these big companies, they need a way to start collaborating around these ECMAScript revisions. They will need to update and modernize the language as fast as possible, because as of ECMAScript 5, there was no major updates to the language. However, there was a need to update the language because all of these frameworks, all of these libraries were being pushed out. Some were getting some very interesting animations and interactions and dynamic interactions on the web pages, and the current kind of ecosystem of JavaScript at the time of 2011, 2013 was not enough anymore to sustain that growth. So again, in 2015, with the 6th edition of ECMAScript, is where JavaScript becomes really the thing. It starts to take over other programming languages in popularity. It starts to really grow, and up to today, I've seen the last report for 2012. JavaScript is still the top kind of used language in some reports. For example, the GitHub's report, it's the top language used in, for example, GitHub projects. And GitHub is one of the biggest code repositories in the world, if not the biggest. And the language and the libraries, Node.js, JavaScript started to be used on the server side, and then with Node.js, we have people writing JavaScript on the server side. And with React.js and Angular and then Vue and other frameworks, we have people writing JavaScript on the front-end side. And the benefit here is that you do not have to hire two different kind of people to write code on the server and on the front end, because if you go with Node.js and, for example, React or Angular, you can have one engineer who knows JavaScript really well, and you can teach them to write that JavaScript code on the server, which is Node.js, and you can also teach them the library, the framework to do the work on the front end. And this is where this is basically the concept of the full stack engineer. So this concept begins to get really lots of traction. A lot of people with Node.js being stable and used by like huge corporations like Netflix. By the way, whole infrastructure of Netflix is Node.js. They are just big in Node.js. It's Node.js only. Not Node.js only, but they heavily invested in their Node.js infrastructure. So Netflix works on Node.js. I just cannot name one big company who does not use Node.js. when I was working at IBM, we even had a dedicated team who would support our own version of Node.js, and that would be the recommended version to use. So it's super huge and irreplaceable at the moment for a lot of companies. So that's the benefit of having kind of the same language, having a modern JavaScript language for both the server and the front end. So starting 2000, I would say 15. That's where actually these companies started getting really serious about JavaScript. They start pushing their own libraries. Facebook has its React, Google has its Angular, and some other companies try to do stuff on the JS community, and it really booms, starts to grow exponentially. So the other Rubicon of JavaScript, except for the 1995, the inception, and 2008 and 9 of the creation of Node.js, and then the fifth revision of the language. The other Rubicon, the point of no turning would be 2015, where all these companies really start getting serious about JavaScript, and that's where we have it modernized. We have new language features pushed every year. We borrow some features from other languages, like when we get to working with promises, we will also learn the async await syntax. We basically borrowed it from C#. They also have the async await syntax there. Okay, so unfortunately, we have another 4 minutes before we're cut off. I'm really sorry about this. We'll try to handle this after this session. So just to quickly sum up, it would be my last screen, and then we'll do another 5 minutes of break, and then let's connect to the call one more time, and we'll do a round table of introductions, and then we'll wrap up today's session. Okay, so let me try to explain the concept of use strict in 4 minutes. We have exactly 4 minutes left. Okay, so we know that JavaScript behaves really strange in some cases. And in the beginning of those engines like Internet Explorer, of Netscape, the early days of Mozilla browser and Google Chrome, they started developing things in their own way, right? They were not aiming for a standard way of doing their things. It also is expressed in having, for example, CSS prefixes. Like each company, I don't know, Microsoft, Mozilla, Google have their headers on prefixes, whatever these are, we might discuss later. So what I'm trying to say is, in the beginning of time, they were just trying to do things in their own way. They're not looking for ways to standardize things, and that's how these engines started to introduce things that were also strange, but they wanted to have their kind of own signature on the internet, so they would just do things in their way. And so when these companies came to realize that things are going to their things are getting out of hand, they also introduced this strict mode for ECMAScript 5. ECMAScript 5, because starting from ECMAScript 6, this is the default behavior. And with ECMAScript 5, they introduced this strict mode, and there are some limitations and more validations on the engine side when you enable this. So just a quick comment here, as I'll be sharing the slides with you. I'm not going to go into the deep details of what is written here. We might discuss them in one of our future sessions. But for example, one point we can discuss is we have talked about these reserved keywords, which you cannot use as variable names. When in strict mode, you can, for example, also not use the word eval and arguments and the word with as variable names. These are actually things in JavaScript, and an eval, let's say, is a function, and You do not need to know what it is because it's evil. So eval is evil. So don't. I'm not trying to. I will not teach you about that. You can look it up if you would like. Yeah. So with Ustrict, we're bringing in some more validations on the engine side, and trying to, and the engine in that way will try to help us to write some better code, right? So again, if you are targeting for any reason, I'm not sure why would you try to target your why would you even write some code in ECMAScript 5 nowadays, because all the other language specifications are really supported by engines, Node.js, browsers, etc. So no need to write ECMAScript 5. But just so you know, this is part of the language, this is the history. So just so you know, there is a strict mode. If you write in ECMAScript 5, you should enable this. Okay, so I think that's it from my side in regards of the presentation.